What's up? Alright, this evening we're gonna do some more programming on this game I've been working on called OmniQuiz.
Hours of dancing at all, the above, hours of life, hours of love, hours of dancing at all, the above, hours of life, hours of love, hours of dancing at all, the above,
Don't really understand this stuff? Well, you don't need to understand all of it. I don't understand all of it either, but it's good to try and learn new things, I think. Even if it's really difficult. I actually have a learning JavaScript programming tutorial in the link of my Twitch chat, so I have a bunch of YouTube videos on learning JavaScript. App.js, yes, this is JavaScript, and then we're going to be doing a bit of HTML and CSS as well. So what we're doing is we are making a quiz game that automatically generates a quiz from a Wikipedia article. So you can just like type in a topic like quantum fit or programming, and then if you I haven't done the UI yet, but it generates questions and answers so far. So first question: research program, a professional network of scientists conducting research. Oh, this is a broken sentence. I need to figure out how to I think I can actually detect broken sentences like that if there's a capital letter just like in the middle of a sentence. Anyways, software engineer, someone who participates in a software development blank. So you need to select what blank it is. And then the answer is process program. Yeah, this is actually a very broken sentence. I'm going to debug this a bit. I don't have money to pay a tutor. I mean, I learned by watching videos. You can just, lots of people these days just learn through, or you can even just learn just by looking. There's people that just learn just by looking at the code like this and just going into a browser here and typing shit like poop. Alright. Oh, so I actually output the text to gtext. So let's write this. Programming selection of best element. This looks very broken. There are not sentences. Let's try this again. Fill rect is not a function. Oh, that's supposed to be fill style. Huh. When did that get changed? It was just working. I only understand HTML and just make a website for my school task. Well, that's a good starting point. Wait, fill rect. Fairly certain fill rect is a function. bg2d dot fill rect. Oh, because I set fill rect to a string, it's no longer a function. Ah. Okay, this is very broken. This is really bad. The HTML is actually just list elements, which means this code I wrote before to try and strip out all of the list elements actually does the opposite thing sometimes and turns it into just list elements. That's really bad. This thing are totally different. It's more than input, image, and video, and design the interface. Yeah, I mean, I do. Designing the interface is like the last thing I do.
Wants to be the first to say.
So remove lists and unwanted text elements. Let's output the HTML before this and after this. Alright, so that'll save two versions of this HTML string. One in BHTML that happens before it has the elements removed, and then one afterwards, after it's had it removed. So then we can compare the difference. And there we go, because that's green, that means our drawing function is actually working. So AHTML, this is after, BHTML, this is before. Okay, so program may refer to, oh, I see what happened. This Wikipedia page isn't actually a informative page on programming. It's actually just a list of all the other articles that programming is. Oh, okay. I don't get it. See, this isn't good to watch if you're trying to learn. Like I said, I have I actually just did a new episode for my learning program with JavaScript. Like, if you're trying to learn, the best thing to do is like to start at the beginning. Go to like, got a whole playlist here. I just did a new video on creating an integer to binary function. So the tutorials are actually getting pretty complex now, but you start at the beginning, you do like the Hello World tutorials, you build it up, you shouldn't need to download anything, you just open the console here in your browser. Hello World is just doing Hello World like this. And then you've done Hello World or alert, Hello World. There you go. It outputs alert with code. So that's the beginning. And then in the next episodes you get into stuff like variables. Build up. Alright, so let's see what this looks like after parsing. So does this actually have broken HTML? Is that why this is happening? Let's look at this. We've got UL. It actually shouldn't be. Actually, yeah. Removes this because this is a title. It's a header, so it removes that, and then the list starts here. Starts a list there until it ends right here, so that gets removed. that header gets removed, it starts another list, which ends right here. It starts up another one. Ends as a little title. Starts up another one. Okay, where is it getting this text from? Mathematical programming or optimization? Software engineer, someone. Right here. It's a UL programming language. It's an artificial language. This is really weird why it's taking this specific data. Oh, so that ends there, and then there's just the HTML is broken. The HTML is broken. I wonder if I should detect HTML and just refute broken HTML and just refuse to generate a quiz from that. How would I detect the broken HTML like that? You can actually see the /UL ends here. Oh, I know what's happening. UL begins up here and it never gets closed. Maybe. Yeah, like it doesn't make sense actually. I just think the actual HTML on this page is broken because it doesn't open up another list element here. Whatever. I guess I just found a huge edge case. I'm still curious, how would I detect broken HTML in this? Maybe if it never detects the ending. Let me actually look at this. No, okay, so it does find the ending.
How do you stay motivated in the midst of everything that's going on? How do you build your personal momentum, and how do you get in the zone, right? And I'm glad you asked. 3 things, you better catch it. My mother used to say, people love to watch a fire burn, all right? So there's one thing I know about life. One thing I know about life is a guarantee, right? Change is inevitable.
Well, anyways, I think that's good. Let's actually set up the answers to be answered now. Let me actually try a different topic.
All right, here's my last one. My last one is Carl, you got to give me that term again. It's spontaneous combustion, I think is what they call it, right? And what happens is when a fire starts to burn, right? And
I guess I'm just gonna do a bunch of buttons, really easy to do on mobile.
Right? And it starts to spread when a fire starts to burn, right? And it starts to spread when a fire starts to burn, right? And it starts to spread. You're gonna bring that attitude home. All right?
Alright, so this canvas is the background. You know what? I don't think I'm going to do any... You know what? We're not going to focus on the text tonight. We're going to make a cool looking background. We're going to do something kind of fun. So I want to kind of make a wave simulation where when you move the mouse around, it kind of creates this animated wiggling background. So, first of all, what we're going to do is we're actually going to resize the canvas to the screen, or to the screen aspect at least. So I'm going to calculate the aspect by calculating normalizing, doing a simple normalization, the width and height to get the X and Y aspect percentages. And we're going to scale that by the size. Alright, so that'll give us the aspect X and aspect Y percentages, and then with that we're going to calculate the actual size. And we're going to set the BG canvas width and height to that. Just back, what's that? We are going to create an animated background. So right now we're resizing the canvas whenever the window size changes. So we added an event listener to the window resize function, or the window resize, and then it calls our resize function. I've seen that before YouTube in those videos. Okay. So then we're actually going to do a pixel per pixel animation. So what I'm going to do is I'm actually going to get the image data as well. And we are going to set up 2 float arrays to do our wave simulation. So now I actually need 2 float 32 array buffers for this, because the wave simulation I'm doing is going to use the last frame to calculate the wave delta or it's like a part of the Laplacian. It's kind of complicated. I'm not really going to be going into the algorithm, but it's the classic wave equation. I'll watch later. Thanks for the playlist and your video. Thank you. There's always more coming. I'm hoping to extend those. I'm trying to do those tutorials so that they can just keep going and being extended to more and more things. Like eventually I do want to do game dev in those tutorials, but after I've introduced the other things that you need to know. Or not necessarily need to know, but will help a lot in understanding it. I might actually need another... I might be doing this wrong. Thinking about this wrong. We'll test it. My friends told me that they always update their language. That's hard news for me as a beginner. I mean, the language itself isn't updated. It has a constant syntax. It's what's called the API that's updated, the programming interface, and those are things called functions. It's basically like new features constantly being added. Like, you don't need to learn the features. And in my opinion, no one actually fully keeps up with the features. The fucking web developers themselves seem to forget that they've added features. So, like, yeah. And there's so many abandoned things as well, it's probably a giant waste of time to try and jump on the new things. Alright, so at the beginning we're just going to draw our buffer. So we're just going to loop through the pixels in our buffer each frame. Draw them to the image data, and then draw the image data. Alright, so this loops through our pixels. We need to get our pixel data with image data.data or image.data. And I'm going to access the pixels with an index, so this pi variable will be the pixel index. So just to begin, I'm actually going to set it to a gradient just to test, so it's going to be from red. So black to red on the x-axis, and then black to green on the y. Alright, so this is red, green, blue is 0, and then we need to set alpha to 255 so it's not transparent. Opinions are very useful. Thanks. Now I just need to wait for a laptop. So you said that you're on a phone, right? Or if you're on Android, you can actually go and just start JavaScript programming. First of all, there's apps on the App Store, JavaScript sandboxes. You can look those up. I think there's like Firefox as an official one. But if you have a text editor on your phone, you can actually like go into notes or whatever, save a file as .html, and then you can open it in Firefox or Chrome on your phone or tablet, and you can actually do programming on your tablet and phone now. That's part of the reason I also think JavaScript is so crazy good, is because it's literally on everything. Alright, and I'm going to do some programming here so that this is just enabled at the beginning, and so that I don't need to do this whole thing each time. I didn't say anything about job. I said you can do programming on your phone or tablet as well. JavaScript has, I don't know if I'd call them emulators. This is all black. Oh yeah, I'm not drawing to the canvas. So what I forgot to do is after we write the pixels to this image data, we actually have to draw it to the canvas with put image data. Just like that. Okay. There we go. So that's the gradient I was talking about. It goes from black to red and then black to green on the Y. Alright. Now let's try doing our actual simulation. I think I'm going to do the simulation in the for loop here as well. So I'm going to have WI, which is going to be the wave buffer index. And I don't think I'm going to have it loop around. I think I'm going to have it bounce across the wall, maybe? Yeah, I'm going to have the wave bounce off the wall. It's interesting though, bouncing off the wall is technically very similar to having it wrap around. Whatever though. Gonna replay this stream later, I'm confused. Yeah, so all these streams are also up on YouTube. So the whole idea is that way you can just pause and you can just stare at the code at sections if you want to. Okay, so output the wave buffer. I think I'm just going to clamp it and send it on its way. So we're going to use math min and max to clamp it between 0 and 255. Because that's the only, the pixels are in bytes and that's the only valid range for bytes.
What we did last night?
And I just realized this is gonna be in black and white right here at the beginning, so I just need to do this once. Just like that. Alright. Yeah, so I'm going to do this right here. I'm just looking, how do I do this? I read the last state, take the Laplacian, store the Laplacian in the last frame. Maybe? I think I'm actually going to test this in ShaderToy first. Because that's the way I test things. It honestly allows me to write stuff just really quickly. Just to test. So let's go. I'm gonna copy this. And I already have the code for doing this, so alright, so this is going to be a lot different. This isn't JavaScript, this is GLSL shaders. And I'm probably going to need to do something different to display this. Hold on. Oh, I forgot to feed the buffer back into itself. There we go. Okay. So this is probably very confusing to see. This is the wave simulation I was talking about doing. This is it as it runs. Yeah, it is confusing. It's like is actually a lot different than what I was displaying in my original program with this, but let's see if we can get a decent display. Yeah, whatever. Anyways, what I'm trying to do is I'm trying to do this with one less buffer. So we're trying to make sure it gets this same result, but without using the Y component. So I can't remember how. So basically right here where it's using the Y component, it's using a two-dimensional field. I'm trying to make it use a one-dimensional field, but then just store a second field, which is technically a Y component, but it's like still doing it a different way. So I can't remember. I think I'm just supposed to record the last frame. Or I guess I can just do it right here. What if I just do equals? Oh god, yeah, that's broken. Actually, hold on. I want to see if I can just find code for what I'm looking for. So this was what my original code was based on. Was this Schrodinger equation. I didn't know this guy uploaded a photo. Alright, let's check this out. I can't resist checking out one of Wyatt's shaders. These things are normally so cool. Meandering currents. This is like a tentacle monster. Fork of fluid reaction, 4 substance and multi-substance. You know what I've learned as my time as a programmer? The best code and the most advanced and most complicated stuff never has comments. Never has comments. Alright, let's see. Let's see if I can find I think either him or Rory that have the wave equation I'm looking for. Maybe not. Maybe not. Or this guy's just done so many shaders that I'm not going to be able to find it. No, I just went past the Fourier transform fluid, so wave equation. Let's just try this. It's more hard than math. Yeah, this is a special kind of math. Oh, maybe this. A minus B plus mean. Yes! Okay, this is it. This is what I was talking about. Okay. A minus B plus mean. Okay. Yeah, this is it. This is it. So I actually believe I would need 2 buffers to do that, which is exactly what I would try to do here. Yeah, so this is actually a different way. It's interesting to me. It's a different way of doing the same thing I'm doing here. As far as I'm aware, I actually want to just check to make sure this actually has the same results. So BA, AB. If I suck at math, can I be a programmer? I think it's more like if you like programming, you can get good at math through programming. Alright, so now what we want to do is this equals x minus the last state, which is channel 1 instead, plus the mean. Is it plus the mean? Yeah, plus the mean, which we have right here, which is D. Actually, is it the mean of the last? Whatever, let's try it. Why didn't that copy? There we go. Okay, that is definitely... Hold on. That's interesting. That's definitely broken because it's not forming a proper circle. What am I doing wrong here? 0, which is B, minus 1, which is A, plus the mean, plus. Oh, I'm doing the minus S there. Boom, there we go. There we go. Okay, so that's exactly what I'm looking for there. And now I want to check something. I'm pretty sure there's negatives here. So I'm going to take away abs and let's see. Yes, so those areas were all negative, which is all right. It just makes me think how I'm going to display this in the actual code here. Alright, there we go. So now I know exactly how I want this to work. So this is why I love shaders, is like, you can just go in and just prototype some math like this so quickly and just test it out. Can I add this on an animation 3 and make a wave crash? I mean, maybe. Like, you're talking about crashing waves. There's actually the same guy that did another one of the ones I was just looking at. Did a really good implementation of a fluid sim. This is insanely good. Like, the currents here are so damn realistic. This is like... Yeah, really interesting thing to me about this was actually in an open paper by the University of Toronto, and it actually got taken down. So I don't know if, like, don't know if the professor who wrote that left the university or what. I don't know why that stuff got removed, because that was so useful to me. I've been trying to actually find that original paper, but it was so, man, that's something where like I think I'm one of the like 100 people that's probably seen that paper. I mean, like, fuck, dude. I should have saved it. I should have saved it. Alright, we're gonna switch up the music a little bit. Here we go. Okay, now let's implement this wave series or whatever in JavaScript. So what we're gonna do is we're gonna take the mean first right here, because this is actually the hard part. Create this variable called sum, and then we're gonna actually I'm not gonna loop. How do I want to do this? I guess I'll check if the coordinate is actually going to go off screen. So I'm going to sum these one by one. So for example, I just figured out I can actually calculate this each y loop for the y. So I'm going to create a variable called y up, which is going to be a boolean that says whether or not the y can move -1, move up by 1 without going out of the buffer. So check this just with if y equals 0, or does not equal 0. And then y can move down if y is bigger than, sorry, smaller than height. Y plus 1 is smaller than height. What the programmer can do without if? Oh, dude, you can do anything without if. Yeah, there's a... So basically the way parallel processing works is what you would do if you wanted to remove an if statement. For loops get insanely complicated without this, but if you just have like an if statement like this, it actually runs both sections of code here. But there's just what's called mask operations, where it actually masks off the operation. So like, it would run the operation of like setting this to empty, but it would like, it's so hard to explain. It's like, it mostly only works actually with vector math, now that I think about it, because it works with real numbers where you actually mix and step between the one result to another. Mask, yeah. Select which values you want to use, basically. Alright, so now we can check if the x is out of bounds just the same way. If x equals 0, then it's just, I'm just gonna do 0. So to read this would be... I'm just actually thinking, yeah, the mean comes from the first buffer, so it's going to be wbuff1, the w wave index, then -1, and then we're going to wrap that in a parenthesis. And this is confusing. It's not supposed to be easy to read, but now we're going to do the same thing, but with the other way, checking if it can go to the right. So if x plus 1 is bigger than or equal to width, and I'm actually going to store x plus 1 in a variable because we're going to use that. Actually, no, we're not, because it's going to be wi plus 1. Never mind. Alright, now we can do the y by doing if y up. Then we can check the width going up, which the way this works by storing things in scan lines is one y pixel is width pixels across up or away in the one-dimensional table it's stored in. It's really complicated unless you understand the memory layout of pixels in an image. But yeah, doing negative width, make it go up, otherwise we're doing 0. And what I believe should happen is where it does 0 here, it should actually cause the wave to bounce off the wall there when it hits 0, because it should cause a sort of opposing force, as far as I'm aware, with the way the algorithm works calculating the rotation. And it's now just doing the same thing but backwards, so we do plus width. And now to take the sum of that, we need to multiply it by 0.25, so it averages out. There we go, there's our sum. So that's the hard part. Now, to just calculate the next wave value, we actually do wbuff. Let me actually look at this. What is it again? Is it is it the first buffer minus the second one? Yeah. First buff minus the second buffer. wbuff1 minus wbuff2 plus sum. There we go. That is the next value for the wave. And then we're going to output this to the wave buffer. I was actually thinking, where do I need to output this? Do I... If this is the second one... Here's the first. So I just realized I don't just need the last state. I actually need the second last state as well. It's the last state. Wait. I think I'm confusing this. wbuff1 becomes the new last state. wbuff2 becomes the new state. Okay, actually I got this. And now, then we do the clamping here of clamping the wave. And I'm going to do absolute value, at least right now, so that it outputs some positive values. Alright. And then, what we also need to do is we're going to swap wbuff1 and wbuff2 because that's what you need to do, because the last frame becomes the next frame, and yeah, it's complicated. Anyways, this should be completely blank to start. I just remembered, so we're gonna add something. We're gonna add mouse input, or actually, you know what? I'm just gonna add something to the wave. I'm just gonna add some energy so that hopefully we do see something when I run this the first time. uncaught, x1 is not defined. Oops. Alright, now let's try again. There we go. Okay, it actually worked. You can see right there, there is some issue it looks like. I don't know if that's not a number or what. Let's look at this. Yeah, not a number. So let's see, does the wave buffer actually initialize to not a number? Yeah, it looks like it does. What if I just don't update it? Let's see, what does it initialize to? Oh, Bunny Rabbit is making a nightly appearance. Alright, actually it looks like it initialized all to 0. So that raises the question, where is the not a number coming from? I'm pretty sure, pretty positive that it's somewhere here reading out of bounds. It's reading one of these out of bounds and not checking properly. Smaller than equals to height. This is supposed to be smaller than height. That's it. So what it was doing was when it hits the bottom. There we go. Awesome. So you can actually see the waves hit the wall and bounce off. Beautiful. This is exactly what I was going for. Exactly what I was going for. Okay, so then the one thing I just want to do is let's add mouse input. Mouse input. And I'm going to slow this down a little bit just so that we can do it frame by frame. You can actually see the wave spreading out there. It's kind of cool. Alright, I don't know if I'm gonna have it so that when you press down it does it. Yeah, I think I'll do it. So we're going to read all of the mouse events. I'm going to have a state of whether or not, call it waving. So when the mouse is down, you're going to be waving. When the mouse is up, not going to be waving. I'm going to do wave X, wave Y, and that's where it's going to be drawing the waves. How am I gonna do this? Actually, I think I'm just gonna do it here. So if waving, and then we're gonna take the X and Y and convert it to the canvas space. So first of all, we're going to normalize the X, the mouse click, by doing divided by inner width, divided by inner height, and then we multiply this by the canvas size. Alright, and then actually, if we floor that, it'll give us the result, which will give us the X and Y of the wave image that we want to draw at. So then we do wbuff1 nx plus ny times canvas width, because the Y is moved across the stride. It's it's complicated to explain unless you understand like the way pixels are in images. Anyways, and then I think I'm just gonna add. I'm just gonna do plus plus, and then you can keep moving your mouse. Let's see how that works. Yeah, so you can see right there. Alright, let me speed that up a little bit. Yeah, I'll probably do a little bit more. Let's do plus equals 10, I don't know. Oh, it just constantly runs. Is mouse up not working? Oh yeah, I'm doing wave instead of waving. Okay. Well, there we go. So I definitely need to attenuate the waves when it's at the corner or edge here. Background slash room is so dark. Yeah. Hold on, let me actually see something. Yeah, I'm gonna be finishing soon anyways. So this just kind of looks like a mess right now. So I actually kind of need to attenuate it so that these things don't just bounce around forever, they eventually disappear. I'm thinking each time it hits the corner or edge. So I don't know. I don't know if I should do that right here. Looks like clouds in pixel. Yeah. It's cool how like bigger forms end up forming and kind of moving across it. Alright, so it's a bit slow to check the border each time I do this. So I think maybe just looping through the border might actually be best. If I just do a complete separate loop here just through the border. So I'll do the X position, or the across the top and bottom first with the X. And I actually need to do this twice. So we'll do Y equals 2, or Y until Y is 2. And I'm going to reset the wave index. Actually, the wave index is going to be equal to the Y minus 1. So that way we can do it twice. And then all I'm going to do, I think, is just take the next wave value like this and scale it back by a certain amount, like 0.9, or so which will take like 10% off it, and then do that again for the Y. So instead we do X this time. How do I do this? This starts at, oh yeah, this is width minus 1 this time. And then WI is actually plus equal width. Alright, there we go. So now the wave should disappear when it hits the edge or corner. I'm almost wondering if just scaling down the value over time would just be better, so that way it just bounces. Thanks a lot on that. I'm gonna come back really soon. Well, I hope you have a good one, whatever you're doing. Yeah, so you can see it kind of disappears when it hits the edge, which I almost feel is worse. Let's see how long it takes to disappear here. Yeah, it seems like it's still taking a pretty good... I don't want the waves to last this long, I think. I want them to actually disappear pretty quick. So I'm going to try something else. Instead of doing this, let's just try scaling back this wave value by, hell, 10% each time it runs. So this should just disappear pretty quickly, yeah. So then if we do this, it just disappears. So then if we want it to last for a while, we actually need to have it output some giant amount, like 1,000. Yeah, so, okay, let's try and tune this to, like, just the right value. I definitely like this, I think, having it disappear over time instead. And I'll speed up the simulation a bit for this. Yeah, so it is slowly getting smaller here. I actually think this is a good rate. It just slowly dissipates and kind of makes room for us to do new waves like this. I don't know, maybe make it dissipate a little bit quicker. Hold on, I'll be right back. Alright. So I'm going to try 9-8. And I'm thinking I can always change how the waves are displayed afterwards to like up the gamma and make them much more visible.
So I wait for you to take me all the way, take me all the way.
Watching.